Greetings, students. Today we're going to discuss practice test 1-3 for geometry. Let's begin. Question 1. This is the angle addition theorem. So the smaller angles make the larger angle on this diagram. So when I'm looking at this, DUV, angle dov, is this angle underneath. So I'm looking for the smaller angle. I'm looking for this. This is what I'm looking for. So in other words, to get the smaller angle, I'm going to subtract the larger angle given, tov and tud, to get that smaller angle. 73 minus 24. Again, you have to be attentive here to which angle you're looking for. Whether you're looking for the smaller angle or you're looking for the larger angle on the diagram. So I'm looking for the smaller angle here, not the entire angle. I'm from given tov. I'm looking for dov. All right, question 2, the segment addition postulate. So with this question, the two shorter lengths add up to make the entire length. So I'm going to take x plus 22 plus 2x plus 28, and it's going to equal the 20. So take x plus 2x, that yields 3x, because x and 2x is 3x. I take 22 and 28, that yields 50. 3x plus 50, and it's going to be equal in value to 20. I take 50 from 20. In other words, I subtract 50 from 20, and I get negative 30. And I divide by 3 to finish my question. I shouldn't say finish the question because that's the value of x. I asked you for the value of FE. So FE will be x plus 22. So to actually finish the question, the segment FE is equal in length to negative 10 plus 22, which is 12. And I can verify my work because this other length here should be 8. So if I put in negative 10 for x here, negative 10 times 2 is negative 20, plus 28 is 8. So yeah, 12 plus 8 is 20 in total length. All right, next one, find the distance. So to get from the point A to point B, or from these 2 points, I can start another point to get to the other one. I had to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. So it went up 9. And it went right 1, 2, 3. Again, the formula here is that the distance is equal to the square root of the change in y squared plus the change in x squared. So the change in y squared is 9 because it went up 9. I shouldn't say the change in y squared. The change in y is 9. And then 9 squared is going to be 81. The change in y squared is 81. The change in x is going to be 3. So I'm going to have here 81 plus 9, or the square root of 90. This is reducible in this case, because 90 is 9 times 10. So I will reduce this by writing this as 9 times 10, or 3 root 10 is my finished answer. So when you're looking at this question, or when you're evaluating this question, the main concept here is getting the change in y and the change in x, the slope, in other words, the main thing, and then squaring and adding them will be the secondary thing here. I will be giving points for the reduction here if it does happen to reduce on the test, but the main portion of the question is getting to this 90 part. It is a right-on question. So if you get to the 90, you'll get almost all the points. Question 4 is the same as question 3. It's just written as points instead of as a graph. So I do the same type of deal. The x's went right by 6, and the y's didn't change at all, actually, in this case. So my distance here, again, we're using the same form. The y remains unchanged, 0 squared. The x increased by 6, so that'll be 6 squared. So 0 squared is 0, plus 36 is 36, and the square root of 36 is 6. The distance here is simply 6, because the y's remained unchanged. The x is changed by 6, and the y remained unchanged. All right, question 5. Name each angle 4 ways. Choose the wrong name for this angle. So basically, I'm asking you to choose the wrong name for this angle. I'm going to take this instruction off the practice test. So that's not going to be on yours. Choose the wrong name for the angle. So it is called angle F because that's its vertex. It is called angle 4 because that's the label inside of the angle. It is called angle F, that's the vertex, but it's not called angle E. E is not the vertex. F is the vertex. It's not. So option C is the wrong option. All right, question 6. My goal here is to get -8, and I'm going to get that -8 from the product of 3 times 5, or in other words, 15. All right, so I'm looking at that 15. I'm trying to get that -8. So to make that 15 into a -8, I'm going to have to break it down with a -3 and a -5, or a -5 and a -3. Because -5 times -3 is positive 15. -5 minus 3 is -8. So those will be what I call my two breakdown terms, or my splits for the middle, in other words. So now a -5 doesn't divide evenly by 3. Sorry about that. So my first factor is going to be 3x minus 5. But a -3 does divide evenly by 3 one time. So my other factor is x minus 1. I can verify my work. I've got -5x minus 3x is -8x. -5 times -1 is positive 5. 3x times x is 3x squared. All right, question 7. Solve the equation. So I can either start this by distributing the 8 or dividing both sides by 8. Either will be acceptable. I'll distribute the 8 since that is a more common way to do this. -64 plus a -40r, or you could say minus 40r, is equal to -304. So minus 40r, I'm going to add that 64 over to the -304. Remember, that's a negative. So that's going to change it into a -240 because we have opposite signs there. Opposite signs subtract, in other words, 304 minus 64, 240. And I'm dividing by 40 to get my finished answer, which is 6. So when you're looking at this and you're thinking to yourself, well, is 6 the right answer? Well, 30 plus 8, that's 38. 38 times by -8 is in fact 304. All right, next thing, describe the pattern. 0, 16, 64, 144. This is a multiplicative pattern or an addition pattern, but it's addition by a different number each time. So I would recommend you use multiplication here. So 0 is 0 squared. 16 is 4 squared. 64 is 8 squared. 144 is 12 squared. So the next item here is going to be 16 squared, because 0, 4, 8, 16 squared. For my next number. And 16 squared is in fact in value 256 in value. I might not have the question as large of a number on the test actually than this, as that, but it'll be some sort of pattern question where you're looking at the pattern and you're saying what's the next item in it. Same as the other patterns we've done before, or similar to them. All right, next one, find the endpoints of the line segment, or the midpoint, sorry, find the midpoint. This is where you add and divide by 2. So I can stack the points vertically, and I can add them. So -2 plus 10, those are opposite signs, so they actually subtract. So that's 8. -5 plus -7, -12. And then I have to cut that in half because we're looking for the middle, the average point. So I divide that in half, or I divide it by 2, in other words, to get my finished answer, which is the 0.4 comma -6. You can verify your work here again by verifying that -6 is halfway between the y values. -5, -7, yeah. -6 is halfway between, then 4 is halfway between the x's. -2 and 10, it's 6 away from 10 and 6 away from -2. All right, this next one's a pattern type question. So I've got the endpoint and the midpoint. I'm looking for the other endpoint. So I like to stack these still vertically. -3, -4. I like to leave a space in between them because here you're looking at the pattern, because the middle is going to be halfway between the two endpoints. So if it's halfway in between, it's going to be evenly spaced. So to get from -3 to 6, I had to add 9 to -3. So my other endpoint, I'm going to add 9 to 6. It's going to be at 15. Its x value. Because you have to have it evenly spaced. It's 9 away from the x here. It's going to be 9 away from the x here as well. And the same thing here. From -4 to 5, we also had to add 9. So my other endpoint here is going to be at 14 for its x value. That's one way to approach the endpoint question here. The other way to approach it is that formula we had in the book, where we take the endpoints, then divide by 2 to get the midpoint. So the other way to approach this question is the more conventional way from the book, which I'll demonstrate now. So it's this was your work here, or you could do -3 plus x divided by 2 is equal to 6. Like our book does. And then you double the 6 and add 3 to that. That would give you your x value. And then you would have -4 plus y divided by 2 is equal to 5. Because my y value, my midpoint for my y value is 5. So I'm looking for the other endpoint, the other y value. So -4 plus y divided by 2 equals 5. So I take 2 times 5, I get 10. I add 4 to it, I get 14. So that's a conventional approach. That's the less conventional approach, the one I like better. All right, give me a second, set the next page. Okay, sorry about that, we're back. The next 4 problems classify each angle as one of the 4 options, acute, obtuse, right, and straight. So let's go with the acute angle first. It should be less than 90. That's one, number 13 right here. That's acute. Acute. You can write the word or you can write the letter, I don't care. Obtuse, bigger than 90, but less than 180. So that's this 140. B is 12 is obtuse. Straight, equal to 180. And that's this question 11. And right, equal to 90. That's this question 14. D, B, A, C. In this case. So again, I'm just looking for the definition of these 4 words. All right, next 4 problems. Name the relationship complementary, vertical, linear pair, and adjacent. So complementary should add to 90. So for the first one, I'm looking for something that adds 90. Well, these two make 90. A and B make 90. These two, they don't make 90. These two, they don't make 90 because they make more than 90. And these two don't make 90 either. So complementary goes with question 15. Linear pair should be equal to 180 when they add together, or a straight line. So I'm looking at these two, they don't make a straight line, they make an angle. These two make an X. A and B make an X if you cover up the portions that aren't A and B. But these two make a straight line, the line that's pointing this in this direction. You could say it's pointing towards the north, west, and the southeast. It's polar in both directions, northwest and southeast, that line there. That A and B make when they go together. So that is a linear pair. Vertical, again, is across from each other. Not next to, but across. So that's this one here. Directly across, they're diagonal. They make an X. So the X here signifies vertical. The X, in other words, the X next, when they're across from each other, not next to each other, like so. So that is vertical. And then adjacent is next to each other. Now, 16 is one example of adjacent. 15 is also adjacent, and so is 18. These two are both also adjacent as well, but we want the most specific name. So, in other words, when I ask you for the relationship, I'm asking you for the most specific name. Adjacent angles can be complementary, and they can also be linear pairs, or they can simply just be adjacent angles. So the answer adjacent only applies when it's not complementary or linear pair as well. Okay, question 19. These are vertical, so these will be equal. So 3x plus 2 will equal 38, so I'll take 2 from 38. And then I'll divide by 3 to get 12 for my finished answer. All right, these are not across from each other, but they do make a straight line. So I'm going to add these and set it equal to 180. So I take 77 plus 1, I get 78. Take 78 from 180, I get 102. And then 6 in the 102, well, 6 goes into 60 10 times, and then 42 more, so 17 is my answer. There's 42 times, 42 is 6 by 7. It did just say solve for x, so I don't have to plug that x back in to get the angles. I could plug the x back in here and verify my answer very easily. So 6 times 17 is 60 plus 42, which is 102. Add the 1, that's 103. 103 plus 77 is 180. Same deal here, I could plug this 22 back in. 36 plus 2 is, in fact, 38. So those two are equal angles. These two are supplementary, as we discussed before. Find the area of question 21, and then we're going to find the perimeter as well. So the area is when you multiply the two values, so 6 3/10 times 6 3/10. So 3 by 3 is 9. 3 by 60 is 180. So that's 189. 60 by 3 is the next thing I'm doing here. So I got 18. 3 by 6, 18. And then I 36 plus 1, 37. Add it all up. I get 16 here. I got 39 and 69 hundredths. That is in square feet. Has its area. So I put the answer in square feet. That means again that it's an area. It doesn't mean we're trying to square the 39.69. We already squared the 6 3/10. That's how we got our answer. We're not trying to square the 39.69. All right, the perimeter, we add the four sides together. In this case, the distance around the shape. So I can either do 6.3 plus itself 4 times, or 6.3 times 4, because there's 4 sides of 6.3 here to add together. So either times by 4, 6.3, or I add it to itself 4 times. So that's 12, 4 by 3, and then so you can actually write this multiple ways. You could actually write this if you wanted to as 4 by 3 is equal to 12, and then 4 by 60 is 240. So you don't have to do your work like this. In fact, let me show you the other way to write your work. 4 by 3 is 12, and then 4 by 60 is 240. 240 plus 12 is 252. So if you don't like to multiply like I did here, do it like this as well, which might be more appropriate. That might be what you've seen more appropriately in your grade school classes. And that is in feet, my answer. And I forgot my decimal. There's one decimal in 6.3, so I've got to put the decimal back in as well. 25.2, don't forget the decimal in the end. Same thing here, don't forget the decimal in the end on that. Anyways, point values. I intend to make everything on the front worth 4 because those are about all the same length. Or excuse me, those, everything on the front worth 5 because those are about the same length. So there'll be 50 points on the front. There'll also be 50 points on the back. So some of these will be worth 5, and then there'll be some of them worth 4 as well. So I can make that out of 50 since there's 12 questions there. So there'll be 2 out of 5. And the 2 ones that are worth 5 points will be these 2, 19, and 20, and the rest of them will be worth 4. That way it'll end up out of 50 points total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 40 plus 10, 50. Anyways, come in before after school if you want to discuss this further. I'll be here. You can talk with me further. Good luck.